So good evening to one and all. So this is the week 6 session for data science for engineers. Uh, so till date we learned about different things such as R language in the how to code, and for that we utilize the R language. Then we learn the linear algebra to know how dependent, independent, all those kind of things. When we learn the probability statistic, optimization. So all the basics things we learned to start the data science journey. So today we are introducing you to the some basics. We right now we whatever the weeks till now we covered. So that's build the what you can say the mathematical foundation or the background on which you can learn any kind of a machine learning model or something like that. So so today we are starting the first glimpses of some kind of algorithm. So we are starting with the linear regression and all. So this throughout whole session will be on linear regression. Uh, Hope I'm audible to all. Okay. So let's start the session. So this session is about linear regression. I will explain who don't know what linear regression and all. So we will go through the basics of it. So, in the machine learning, so at basics, they will introduce you to the different kinds of problems what we faces in our day-to-day life. We convert those problems into a specific. We do the taxonomy of it, or you can say the classification of those problems. So one such problem is called to be the regression problem, and another problem is called to be the classification problem. That is the basic broad, what you can say, the upper level classification of your problems. So what kind of problem means I am talking about? So we will see in the next upcoming slide, okay, and in the next what I'm going to explain. So what regression is? So we will go to the first definition of it. Regression is a supervised learning that build functional relationship between dependent and independent variable. So we already learned in during linear algebra what exactly dependent and independent variable. Okay, so I will explain here also what exactly it means. Okay, so and you also here have some word that is called to be the supervised learning. So in machine learning, so whenever someone talked about supervised learning, unsupervised learning, or reinforcement learning, it has its some meaning. Supervised learning means you have given a dependent, independent variables as well as dependent variables for it, and based upon that you will train the model. Means it's like a you have given kind of a let's consider the property rent prediction kind of this particular module in which you have given the different features such as the location of the house, then you can say what exactly the square feet number of bedrooms and all those features are given which are called to be the independent feature, and on all those features your price is dependent. Okay, so the price of the house is called to be the dependent feature. So when you have the dependent and independent variable, and based upon that you are going to prepare your model. So here you have a particular variables and answer for that variables or the label for that variable, that is called to be the supervised learning. In case of the example of when you see images, okay, let's consider you want to classify the image between the dogs and cats, whatever the image feeding to your algorithm or the machine learning model. So you want to classify between the cat and dog. So for first of all, to prepare all these model, we require the data. So when we collect the data, so for each different images of the dog, we will have some label to it. Means this is the image of a dog. So that kind of X we have and a Y answers for that we have. So such kind of learning called to be the supervised learning when we have X and when we have Y. Unsupervised learning means we only have the X values. We don't have Y. Means you have the image, but you don't know what exactly that image. So your algorithm will try to learn out of that also. So that is called to be the unsupervised learning. Okay. So in case of a you can see the movie recommendation and all those things where they don't know means they don't have the Y levels for it. So they just have the X, and based upon that they are saying so clustering and all. When you try to purchase something on the big Flipkart, let's consider if you purchase the laptop, then they know what is the nearest thing that you are able to purchase. So they know by distance that you are going to purchase a laptop bag for it. So that way they are recommending you just purchase this bag also. You can add this bag into the cart. So such kind of learning called to the unsupervised learning, where you just have the x values and not the y values. So here I generally x means in the data science, x generally they represent for the independent feature and y generally they represent for the dependent feature. Okay. So whenever I am utilizing this x and y, so remember that thing. Okay. So here I give the two example of the linear regression problem. One is the predicting property prices. So let's assume you are in the Bangalore city and you want to go on the different website. So they will say that choose in which area you want your particular property. Okay. So you will choose, I want a particular Whitefield is a particular place in the Bangalore. You want the property in Whitefield. Okay. You want to rent the property in Whitefield. So you will put that. Then how many BHK you want? You will put 3 BHK I want. What the square feet you want a plot or you want a flat kind of thing, and how much distance from the met. So based upon all these things, your property that your model give you the price of that particular house like that. So that is one of the regression problem. Another one is stock. So based upon stock is what exactly the stock price today. So so they for that they will have the stock price of the past few years, and then what exactly happening within that company or within that country. Based upon that you can predict the stock price all. So these are kind of a prediction problem where you have some variables, and based upon that you are predicting something. Another problem is called the classification problem, where you want to classify between the two classes. Classes means here, if I give image, you will classify this image is a dog, cat, parrot, or something. So that's such kind of problem is called to be the classification problem. So that way, these all problems are divided into the regression and classification problem. So let's deep dive into the regression problem, who still not understand. So here I took the house rent prediction. Okay. So this is your model, some AI model. So we will not go into the maths. And it is giving you some kind of a price of that particular property. So here the particular website in which, let's consider you have a particular, you prepare a particular website. So and based upon that you are going to give the recommendation to the user, this will be the particular price of that particular house. So you give the features such as location in the Bangalore is Whitefield. I choose size and area, so I choose 15 square feet area. Transportation means how much my house is far from the metro or the bus station. That is very important, because in city like a Bangalore, if you want to travel by your means vehicle, four-wheeler and all, it becomes very difficult because if you're stuck in the traffic. So in that case, it's important how much bus stand or the metro station is far from your house. Based upon if your house is very near to the metro, then the house of the cost is increased, because that's a very means you can save your time, and time is money. Okay. Again, the house is furnished or not. If it's furnished, you don't require to purchase anything. So that's why the property price also increases. But if it's not furnished, you have to purchase when you have to invest some capital at the initial time when you are going to go into the utilities, whether electricity bills are included in that or not, as well as water bills are included in that or not. Some houses they exclude the utility bill, and based upon that they will put the price. So if utility and all included, the price will also increase. The pets allowed and not allowed. So this is a new thing features. Means if the pets are allowed, then there are some restrictions on society and all. Based upon that, if there are pets allowed at society, so there also the prices increase because they are allowing the pets to be stay, and there are some other stuffs regarding. So all these are called to be the features. They are independent in itself. Okay, on the basis of these features your price will be decided. So that's why this is dependent feature, because on this your house of the price is dependent upon someone. So it is dependent upon all these uh, six feature. It might depend upon other features, but for the example I just gave you the simple example of six features. So that's what exactly the regression example or the regression problem looks like. So you can consider another example is stock price prediction. That is one of the things. There are many such things you can find in your day-to-day life. Okay. So now we will categorize how the different regression problem is. One is the univariate versus multivariate. Uni means one, where you have only one independent feature, and based upon that you are predicting your Y value. Okay. So here you are able to see square foot and the house of the price. So right now someone will type based upon square foot, I will tell you the house prices. So this is kind of a univariate case. Okay. But you know that house prices cannot be just decided with the help of the square feet. Okay, so it can be just decided. You can add another feature. So this will you should know why it's important to add more feature, because if someone gave you just square feet and you try to build a model and it will give you the house price prediction, so your model will be kind of not much robust because you are just considering one feature. But someone gave you square feet as well as how many number of bedrooms, because it's all about the how you plan your whole your house. Means this is 1500 square feet, still has three bedrooms in it, so that is also one of the factors. So based upon this factor, you are able to know the house pricing. Whenever you predict the house pricing, that will give you the kind of exact pricing. All if we include all these features, then it becomes very close to this particular house pricing. There means number of more features which are relevant feature, not irrelevant feature. If you take the number of more relevant feature which are contribute to the house pricing, then that model will give you less error, as well as the model which gives you the less error, that is the more robust model, and people going to utilize that model. Okay, so that's what exactly the importance of univariate and the multivariate kind of regression problem. That how you can divide. Another way is the linear versus the non-linear. So this is the example where relationship between the your independent and dependent feature are linear, then it's called to be the linear. If it's a non-linear, then it's called to be non-linear. So that's a very basic stuff. Okay. Next one, regression problem are kind of a different I mean, different regression problems can be have different ways you can do the linear regression thing. Okay, so first one it's divided into the linear and non-linear regression. So in linear regression, one is the ordinary least square regression, ridge regression, lasso regression, partial least square regression, principal component regression. So why not there is only one, such as OLS regression is the simplest regression. Why not we have just the OLS regression? Because the reason behind this is each regression has its own benefits. So ridge regression and lasso regression has its own benefits. So why people, these are the kind of advanced version of this regression. We will going to see the mathematics of regression. So don't be confused that what I'm talking and all. So we will go in much detail. So for now, I'm just telling why not there is only one regression. So these are the advancement of the OLS models. You can say ridge regression that will tackle if you are a multiple number of independent feature, but which are correlated with each other. So in that case, lasso or the ridge regression come into play, and that will give a zero weight to that particular feature. Means if two features are highly correlated with each other, so it will eliminate one feature, so that your competition will also reduce, as well as you will get a more robust model. Okay. So that way, and partial least square means if you are not finding any kind of a feature, any kind of a relationship between independent and dependent feature, then we are going to the another space. So it's kind of a principal component space. And in that space, it's a linear combination of all feature that will give you another. Uh, it's a conversion of it's converge up in your real space into the another imaginary space, and in that imaginary space we are building the model. So such kind of model also have its own benefits. So all those are the linear models. Then next one is the non-linear model. So polynomial regression means here we are just having the x values. In the polynomial regression means where you are considering the x square, means ax square, ax plus bx cube, and all those kinds of things. Neural network is kind of a linear combination, multiple linear combinations, and spline regression. So all these are the examples, again, in-depth examples of the nonlinear regression. Okay. Now we will move how the linear regression problem or whole regression process works. So first of all, we have to formulate the problem. So formulate the problem, choose the set of variables, form the model, method of fitting, specific assumption. Okay. So first of all, we have to choose our problem. So what exactly my problem? So here I will again give the example of property prediction. I want to predict my property house. Okay, I want to rent some property, so I want to exactly know the property based upon, so on which things this particular property is dependent. So it's dependent upon your location, how much transportation you have from the metro, how much number of square feet it's a furnished or not. So you have to figure it out, which are your independent feature and which are your dependent feature. Once that is figure it out, so we choose the feature, form of model. So which kind of model there are means so many models in the market. So which model you want to choose? So based upon your assumption or type of problem you are solving, you have to choose the particular model. Okay, model. So you will choose the model, and then method of fitting and all, that's the same model. and what exactly the assumptions. So based upon assumption, your model might change. Okay. Uh, which week it's going? It's going a 6 week. Okay, so then next one we have to fit the model. So once you know the model, you know the independent feature, and based upon that, we will do a fitting of that model. So this model we fit here. Okay. The next one we will validate the assumptions. Okay. So there are different techniques such as residual plots, outlier, because if there is a presence of the outlier, okay, then whatever the model you will fit, okay, so that model will, because of the outlier, that will shift a little bit, and that's why it's better to remove some outlier, okay, and that is the better way to do preparation of your generalized model, okay. Then once that all validation is done, then if it's okay for you, then you can do the evaluator. Means generally while preparation of the model, what we will do, if you have the, let's consider if you have 1,000 data points, okay, such 1,000 data points which are the property location and all those data, for that 1,000 value, we prepare such kind of a data set. Now, from that, generally a rule of thumb is 80-20% that way. Means 80% of data we will train our model, and we will take whatever we our model train. We will take 20% data, means 200 points, and we will test how much accurate or how much accuracy or how much error I am getting, mean absolute error. Means if my model predicted some 1,000 value, how much it is deviated from my actual value. So if your actual value is kind of a 1,200 and your model giving some one means 1,000, so it's a deviation of some 200, so you are able to bear you are okay with that particular error, or you want to add more feature and go to more closer. So all that can be decided or tested with the help of that is called the goodness of test. Once that is okay, if it's not okay, then you will, again, it's a looping or kind of an iterative process. If you are okay with that, then we will stop and we will deploy that model into the real production, okay. So that's what exactly the regression process looks like. So we will go to the each steps of this, and I will explain how these things work. Okay. So we will take a simple example. So this is a regression illustrative example I will give you. So here we are just considering the univariate case. So the reason, because it will help you to understand more better. Okay. So let's consider I have a particular car. So I have a particular what you can say, the a vehicle repairing center. Okay. Vehicle servicing center where I number of cars coming to me are shown on the here particular x-axis, whereas number of minutes required to repair all those number of cars, because I have some number of workers and based upon their availability. So these are kind of a number of hours I require or the number of minutes I require to repair the cars. Okay. Because there is a specific time for the workers also. They will come at a 10 o'clock and they will go at a 6 o'clock, that kind of. So I have to manage all those things. So based upon number of cars arrived, I know the number of minutes will require because my number of employees are fixed. Okay, so what will happen? So if the number of cars become 20 and there, I know that specific amount of time from 10 to 6, it's around 8 hours. And based upon 8 hours only, I will take that number of cars from my website. I will not allow or allow more number of cars. I will close, what you can say, I will close my registration or I will close my appointments after that. Once that for that day, if all the appointments or you can say some 50 cars are registered or taken the appointment for that day, I will close my what you can say the appointment whole page. So same when we go to the ticketing platform and all, you heard about the Coldplay tickets and all. Means the sales are out of stock and all. So all those things are here. You can consider here the servicing center case. We are trying to build such kind of thing. Okay. So I have the data of past, and based upon the past data, means let's consider this is the car which where 6 cars coming to my center, it is taking 50 minutes, and here some 10 cars come initially it takes. So there are some variability in your data. It never be ideal because every car has different kind of maintenance is required. Okay, so this is what exactly our model. So what dependent and independent here. So here dependent variable is the number of minutes, whereas independent variable is car that we consider because we want to find the number of minutes here. So here we want to find the best functional relationship between the both variable, which can given by a linear line. Okay, so that this is a simple case help you to understand. So what I will do here means I want to create a model here. So this is a x, and this is your kind of a y, and this is your x. So best way to fit a particular line. So you are able to see I can fit a line that is y is equal to mx plus c. So that particular y is equal to mx plus c is nothing but your model. So I will give you x value, then that model will give me the y value. Okay, that's what exactly it is. So how these things work. So I will initially I will take just a random guess. So take this particular line. Okay, I will fit such number of lines. Okay, take this line, this line, this line, and I find that this particular line give the best fit by particular best fit for my particular model. Okay, you are also able to see from this particular train of the data. So these are the different sample points. Okay, so this black line gives the best fit for my particular thing. Okay, so that's what exactly I want to do. So this is I shown with the help of illustration that how the regression thing works. We will go into the maths of it, and then we will try to understand how the particular how it works in the background and how the mathematics work behind it. Okay, that is the regression problem. So right now, that is we are dealing with the ordinary least square here. That is the kind of algorithm we are going to see, and we are going to see the same problem how the things works in the background, mathematics of it. Okay, so you will know that uh, this whatever the answer, this backline means whenever you run all those things in the RStudio, it will give you the direct answer of this particular. It will give you the you this is called to the intercept y c value, and slope of this is called to be the m value. So it will give you the beta 0 and beta 1 values, slope and the intercept, that it will give you a direct answer. But we will see how the direct answer comes. Okay. So this is how linear model between y1 and x1. Y is our minutes and x is our number of cars. So I have n number of such samples. Okay. So because I have taken the data of some 3 or 4 months, whatever the cars coming to me. So with the help of that data, I prepared this. Let's consider I have the data of 1 year, means 365 points such I have for a number of cars and number of minutes for that. Okay. Now here y is equal to beta 0 plus beta 1 and xi. So if you see, you are able to see this particular line. So this line is nothing but some beta 1, and so right now we are taking generalized. Okay. So here we don't know what exactly beta 0 and beta 1. We just take a random guess, some beta 0 and some beta 1. So this represents the intercept. Beta 0 means intercept, and beta 1 means your slope. Okay. So if you take this particular value, it will give you some this. Plus EI is a kind of a error. Okay. So for each sample, if you try to do this, okay. So beta 0 plus beta 1, this is your line parameters, and xi is your simple, if you consider this particular sample xi. So, and this is particular your line. So how much this particular actual point from this line, so that is covered with the help of EI. So that's a perfect equation. So this is this EI. So epsilon considering the error of this particular error, and this beta 0 plus beta 1, this is particular line. So here you are able to see this is the error from error EI calculated y is equal to y hat. Y hat means your prediction given by your model. So that's how we frame a particular problem. Now what I will do, I will shift this beta 0 and beta 1 xi on left hand side. So what it will become, your error is equals to whatever the error we are calculating, this E1 to En. So this will become yi minus beta 0 minus beta 1 xi. Right now, what I will do, I will means this will give me error is either a negative or positive value. So if we try to what you can say if we do the summation of all those errors, so here the error is positive, here the error is negative. So if you do the addition means if you do the addition of all, so it will addition means negative and the positive effects. There are some negative error, there are some positive error that might cancel out your whole error, and that might give you some zero values. So it's better to not do that thing, simple addition. It's better to do a square of it. Means even that number is a negative. If you do the square of that negative number, it becomes a positive number. So that way, it's better to do a square of those all errors and then do the summation of all those. So this is the sum of square errors, and this is nothing but what we want to reduce. So if you have this particular horizontal line, then the error is too much. If this particular line fits like this, a black line, that is a perfect line, that's what exactly our answer, then that will give you the lowest error. Okay. So we want to minimize the error. So in the optimization problem, we want to minimize a specific function. So here our function is this, error is our function, and we want to minimize this error, and this is our function. So we generally calculated what you can say, the first partial derivative, and then second we calculated the derivative, first derivative, and then we calculate the second derivative. That way we are doing the optimization and all. And we also saw the gradient descent algorithm, with the help of which we are getting closer, because sometimes perfect answer is not existing. We have to go near to that answer. So in that case, we are utilizing the stochastic gradient algorithm. So here also, error in generally the machine learning algorithms, we generally try to minimize the error. So there are different kinds of error. So here it's kind of a mean square error, but in classification problem, it's kind of a different kind of a error. So that's what exactly we generally try to reduce. And as much as we grow near to zero this error, we are getting a good model. Okay, that's how your algorithm learns that's how your algorithm learns your data. Okay, that's how in the background all things work. Here the answer in the case of a linear case, and this is only one feature, means x and y relationship. So there is a perfect answer for it. So how you can calculate? So beta 0 and beta 1 value. So this is the straightforward formula. So this is the covariance between the two variables, and then the variance of x1, which is your what you consider the independent feature. So this is sxy. So if we want to calculate the beta 1 value, that's a slope of this particular your model, then this is the particular answer for it. So this is the variance between two variables, and this is the sorry, covariance between two variables, and this is the variance. Covariance divided by the variance. Okay. And if you put this beta 1 in this equation, then you will get a particular beta 0 is equals to y1 minus beta 1 into x. These are the mean values of x1 and y1. So that's how you can take a snapshot on. Based upon that, the numericals are asked in your week assignment. Okay. So that's what we saw, okay, here, how the model trained and all those things happen. Right now, we got the beta 0 and beta 1 value. Now we talked about testing how goodness of fit and all. So there are different quantities are there. Based upon that, you can say my model is good or not. So one of those is the R square is one of the metric, which measures is one of the measure used to test determine the goodness of fit. Okay. So R square, what exactly mean? R square calculates the variability of output variable by input variable. Okay. So this is exactly the formula of it. One minus summation of yi minus y hat. So whenever someone giving you this y hat kind of symbol, so it represents your the value predicted by your model. That's what exactly it means. So this is y hat is equal to beta 0 plus beta 1 into xi. Okay. That's what exactly it means. So yi is your actual value. Okay. So whenever you are taking the testing data, okay, so you have the actual value also yi minus predicted for that particular sample. You know the actual value. You will do the some subtraction from whatever predicted by your model. So that is y hat. So this will help you to calculate the error between these two. And we are again doing the square because it's kind of a we don't want to do the we don't want to cancel out the effect of negative and positive sign. That's why we are making it a square. Okay. Then total variability. So here we are taking the mean of the particular your dependent variable, and that is a total, that is the variability explained by model with respect to the total variability. That's what exactly the ratio we are calculating and subtracting from 1. So that will give you the range between the 0 and 1. So if your R square actually R square value lies between the 1 and 0, if you are getting the R square value near to 1, then it's a good fit, and if it's 0, then it's called to be the bad fit. Okay, means your R square value is coming towards 1. But here most important thing, here we are considering the model. Also our assumption is the relationship between the y and x is a linear relationship. Okay, if it's a non-linear relationship, then you might then R square is not a better way to use for the non-linear kind of a model. Okay, so that you should have in that you should consider. The next one, to make it more better, they have some existed R square. So it is just a modification of R square, because in this they are not taking consider into account the independent variables. So that's why they are just doing n minus p minus 1. That way they are doing here. Okay. So here n minus 1, because here you are able to see beta 0 and beta 1 is the two features Here only one feature is there. That's why here kind of to balance out the number of independent and dependent feature. So they are doing just and that's why it's called to be the existed R square. So it's just a modification of R square you can consider. So remember this formula, okay? Because numericals are asked in the week assignment on the existed R square as well. Let's look into the numeric some MCQ question of it. So this is the first MCQ question. So it's the in our linear regression equation, what does a slope represent? So I already tell you slope and intercept. So what exactly the slope represents? So read the statement. Okay, so it's a mix of answer A and B. So okay, so the in the okay. So few of you answered a linear regression equation. What does a slope represent? So basically, slope is representing the change. Whenever someone asks you slope is nothing but a change in something with respect to something. Okay, that what exactly slope means. Okay, so here only one option that is satisfying here, the change in independent dependent variable to a unit change in independent variable. Okay, so B is the correct answer. Those who chose A, the intercept of the regression line, that is not a correct answer. So, so slope generally represents your change in independent versus the dependent feature. Even though if you don't, even if you don't have any, what you can say, knowledge about regression and all, then also you can easily answer this because slope means change in something with respect to something. Okay, so that's the correct answer. So here is kind of you can say the explanation for it. Moving towards our next question, that is what does coefficient of determination R square measure in the regression model? What exactly it measures? Just now we saw the accuracy of the model prediction, the bias of the model, the standard error of the model, the proportion of variance explained by the model. Uh, so R square measure the proportion of the variance in the dependent variable that is explained by the independent variable. So this is the B is the correct answer. It's not the accuracy. So generally, um, you can say accuracy kind of, but B is the correct answer. You can say accuracy, but for your information, accuracy when you talk about the accuracy matrix, so accuracy matrix is generally utilized for the purpose of classification model. Okay, not for the regression model. So accuracy has its own formula. So that's why here I not give A as a correct answer, but here I give you B as a correct answer. In random, in kind of a talking terms, you can say the accuracy, but in mathematics, accuracy has its different meaning rather than just saying the accuracy. So the correct answer is the proportion of variance explained by the model. That what exactly the R square help you to measure. Okay. Okay, so right now we saw the all the mathematics and all. So it's better to do mathematically how the things works. So that will give you a more better way, the idea how the linear regression things, all those things work. Okay, so we have following data. So let's consider we have x and y's. Okay. So this is the data 1, 2, 3, 4, 5. That is the x values. And this y 3, 5, 7, 8, 10, 12. These are the y values for it. So first, what we'll do, calculate the mean of it. So I taken the mean of these all values, x and y. So this is 3.5, 7.5. What I am doing, why I am doing here, I want to calculate the covariance and the covariance of the x and y and the variance of x. So for that, all I'm doing here. Then the step to calculate a deviation from mu. So I'm calculating. So standard deviation of the variance, what exactly it means? It means how much you are varying from your mean. So that's what I'm doing here. So this is my mean value already calculated here 3.5. And for each sample, I'm calculating how much far I am. So here for from sample, I'm 2.5, 1.5, 0.5. So all those are values I taken. Okay. Now I'm doing the calculate the variance. I'm just multiplying all those values. So here I'm doing multiplication. So I'm getting the variance of 5.083 between x and y, and a variance of x 2.916. So right now I have xy, xx. So with the help of that, I can directly, I know the formula of beta 1, okay, to know this particular line. So beta 1 here, I mean a slope of the line. So sxy and sxx, if I do that 1.743, that's what exactly the answer I got from it. Step 5, use formula to calculate the beta 0. So this is the mean I know, and based upon that mean, I will put my all values. So I will get my intercept is equals to 1.4. So here I will get intercept 1.4 and particular slope of it. Okay. So the final equation is y hat is equals to 1.4 plus 1.743x. So that what exactly your model is. Okay, generalized model. So whenever someone will say you in data science and all, I prepared the model. So model and everything, it's just some kind of a mathematical relationship. Okay, so this is what exactly the model in this case, whatever the data I provided to you. So it's just a mathematical, you are putting something and you are getting out of it something y value. So this is the simple linear relationship or sometimes a non-linear relationship. That's what. So your chart GPT and other things is nothing but some mathematical thing. So here just we have the only one linear regression. So they have a infinite or the millions parameters. So here we just have the two parameter. Two parameter means beta 0 and beta 1, intercept and slope. That's only two parameter I have and I prepared the model. So whenever means I don't know how many of you watch the video of OpenAI and all those things. So they are talking about I have billions of parameters. So here with the help of two parameter I prepare the model. So ChatGPT they are giving answer of anything. Okay, whenever you ask anything or whenever ask the code and all, they are trained from billions of parameters. So with the help of two parameters also, we are able to do some generalization. Imagine if there are billion parameters, so how much the scale it is, and that is the reason they are giving the good answers for all your tasks, whatever assigning by you to the your GPT models. Okay, so let's consider then once we have all this y hat all, you can calculate the r square out of it. So here our model, you are able to see how much it is perfectly fitting. Okay, so no need to store these particular values. With the help of x only, I can get the y value. So your r square is 0.99 and your calculate the existing r is 0.992. So that's how you can do the calculations and all. So this is how it works in the right now we have the direct answers for it. But when how it works in the if you consider the logistic sorry, if you consider the gradient descent algorithm, how they do it. So this is how glimpses of that example. Here you are able to see here the iterations are following, these are the weights are changing, and these are beta values, and this is the error. So here they are you are able to see error is decreasing 215, 213 fits initially, and then let's see here. So let's wait here, and you are able to see 180. So it start from 270 and reaching 280, and at that time it is reaching this green line is moving, and this is continuous error is calculating. That's how it works in your RStudio. So let me give you some example RStudio. I think I pick. Okay, let's open this. Hmm, Okay, so okay. Uh, so first I will go to my files. Okay. So I will first choose my directory where my all files are there. So okay, let me choose that directory. Text. So I just want to give we saw it means we saw how concept work. We saw it how mathematically by pen and paper how it works. Now I'm going to show you how whether our answers are matching with the algorithms in the RStudio also. So right now you have the linear model. Okay, I don't know. 1578. Let me verify I'm taking the same data or not. Okay, so this is 3, 5, 7, 8, 10, 12. Uh, okay, so I'm taking the same data x and y value, and I'm just want to show you when you do the mathematical and when you do here, so how things work. So I'm just look here. I'm just running my code one by one. So here I have x values, that is the vector appeom. I prepare the y values, and then I'm preparing the data frame. Data frame means just x and y values, respect to x and y values. Okay. Once data frame is framed, here I'm preparing the model. So to prepare the model using linear fitting model function. So there is a one function that is called the LM, which is nothing but a short form of a linear model. So you have to put which is your dependent and independent variable. So I gave the y and x value. So y is my dependent and x is my independent. And from where you are taking this data. So I'm taking this data from data from df. So that's what exactly this particular notation means. So once you have that, just you can assign this particular to the model, and then to the model object, and I'm running this. So right now my model is 10. So you are able to see your model is here. So it will store different random things. So okay, we will not go in depth on that. And then you should see your summary. So when I print my summary, you are able to see. So these are your kind of a residual means. Once I have the model, y minus y hat, that what exactly it is giving. So these are for first sample, I'm getting this much error. Second sample, I'm getting this much error. So for all six sample, it is giving me the residuals. So these are the coefficient. Intercept is 1.4, and your x, that is, this is your slope, beta 0, beta 1 value. And these are your kind of standard deviation and all. We will see in detail what exactly these other values mean. Okay. And here you are able to see the R square value 0.936 and 0.992. So that is a when these questions are asked, so just you can run in your R and you will get a direct answer to solve in the uh, to solve for the your day-to-day assignment. Okay, but I just want to show you the glimpses. So let's verify our result of what we calculated through this, whether they are matching or not. So here you are able to see, yeah, 1.4 and 1.743. And let's see here, 1.4 and 1.743. So there it's kind of a 4.3 means it just a 2 to 8 means we are just rounding off it. And that's way you can see your RStudio and what mathematically we calculated. They both things are matching with each other. That's how the mathematics and the algorithms in RStudio work. Okay. So, so that's how I show you the glimpses of how the things work. Let's go in some numerical stuff, what we just saw. Okay, so we have just I gave you the data. So what is the slope of best fitting linear regression? So you have to calculate the beta zero. So here I have the slope, and what is the intercept means beta zero and beta one value you have to calculate it. So this is the data set I given to you. So those who don't know the formula, just take this formula. So take you can okay. So just take this particular example, and based upon that example you can solve that. Just take a snapshot, quick snapshot. Okay, if you have snapshot, uh, okay, so we will go here, and this is the same question I asked here. So just find the slope and the intercept for it. So yeah, one, two, three, four, five samples I given to you. uh, just calculate first mean and then do the standard deviation and the variance of it, and then just do the ratio of it. Then you will get a beta 1 value. And you already know the mean of x and y, and based upon that you can calculate the beta 0 also. So let's take some time for it. Okay. And because I think three or four questions are asked weekly. In this week, three or four questions asked on that. So it is better if you solve this. I think that will be helpful you. Anyway, you are getting the answer from the RStudio, but it's better to solve by hand to get the concept. Okay, few of you already got the answer for one. B is the answer. Okay, that's nice. Let's wait for the others also. I think they might need some time, or maybe few of you have the RStudio, so they just put it these values and answered the question. Okay, someone got D. Okay. So I think Sangeeta, if such calculation, if there are simple calculation, no calculator will be provided. If there are calculation, then there is a virtual calculator is present during the examination. If it's a digital platform examination, so generally I think on the computer itself. So generally, I don't know whether you know about GATE examination or other examination where the TCS centers have their calculator, so you can calculate there itself. Okay, so B is the correct answer. So Prakash, just check your calculation. Maybe some error will be there. This is the formula which we utilize to calculate the B1. Let's calculate. I think if you have the B1, it's very easy to calculate the B2 question to answer also. So you should know the means of the X and Y and then just put into the formula and then you will have the answer for it. Okay, so we will move forward. I think it's 2.9 answer. Uh, Okay. So, okay, I think Prakash, you already gave the D answer. Okay, you are right. So yeah, your both answers are right. B and D. Okay. I thought you gave answer for the first question itself. Okay. So both answers are right. B and D and calculate the beta zero. That is the intercept is equals to y minus beta one into x bar. That's what exactly. So this is what exactly the calculation. So let's move to the another question. It's bits a twisted question. What is the predicted value of y when x is equal to 6 using the linear regression model? So you have this model. So I'm asking the same question, repeated question. So you know the slope and intercept. Just note the values of slope and intercept. Now the follow-up question on this: what is the predicted value? What is the value of y if x is equals to 6? So just put 6. It's just a state for a y is equal to mx plus c, or y is equal to beta 0 plus beta 1 into x. So these are the answers: 1.3, 2.9, and this is x is equal to 6. Very straightforward, I think. Okay, yeah, you are answering D. Yeah, you all are correct. Hope you got the concept. It's a D answer. It's very simple. Who are not able to solve, it's very simple because we already know the slope 1.3 and 2.9. And then we will give the value of 6 and then it will calculate the value of y. Okay, that's why your answer is 10.7. What is the R square for the linear regression model fitted to this data? So what's exactly the R square? So just go through the R square formula and uh, so, okay, let me open R square formula for you if you are not okay. Uh, so this is the R square formula. So take a snapshot. I think that will be helpful. And you already have other things. So you have to calculate for y minus y hat for everything, and then you have to calculate that. If you took, I will go to 13th slide. Okay. Okay. So this is the slide. What is the R square for the linear regression model fitted to the Prakash? Okay. B. Okay. Prakash, let's wait for the others too. Shreya B. Okay. Okay. Shrihari B. Okay. I think you all got the answer. It's a correct. You all are correct. It's a B answer. This is the formula R is equals to 1 minus summation of yi minus y. So you have to do it for each sample, yi minus y hat and then square. So uh, it's a bit calculative process. Okay. Moving towards next question, what is the mean square error for linear regression model fitted to this data set? So what is the mean square error of for the linear regression model fitted to this data set? So mean square error is y minus y hat. That is mean. Mean square error means you have to square that. That is called to the mean square error. Y, I think you already calculated for the r square, so it's the same. yi minus yi hat whole square. That is called to the mean square error. Okay, 5C. Okay. Okay, Prakash. Mm, let's wait for the other. I think. Okay, so we will move towards answer. So it's a C answer. You're correct. uh, Mean square it means residual whole square residuals to the power whole square. Residual means yi minus yi had. That what exactly the residual means, and you have to do the square. And you have yeah, this is for uh, you have to sum it all those things and divide by, and that will calculate the 3.9 it exactly the answer of it. Moving to the next question, if a slope of a linear regression line is 3 and the intercept is 2, what would be the predicted y value for x is equals to 8? So, don't consider that beta 0 and beta 1 value. I gave new values to you. So again, this is the straightforward answer. Okay, I answered is a B. I think you all got the concept. Yeah, it's a B answer. You are correct. So this is the simple 3x plus 2. That's what exactly. Uh, Now there are different terminologies here. Okay. So because same question asked in your one of the questions in weekly assignment on SSC, SSR, and SST. So I will explain what exactly this terminology means. SSR, residual sum of square. Okay. So SSR, okay. So it's yi minus yi hat. So this particular line represents yi hat. Okay. Okay, and minus yi. So you are able to see yi minus yi hat. Okay, so this particular difference, okay, this shown here with the help of blue. Okay, this difference is called with the residual sum of square SSR. Okay, yi minus yi hat and then whole square. That's what we calculated in the previous numerical. Okay, then total sum of square. Okay, so its total sum of square equal to yi minus yi bar. So this you are able to see this particular line. This is the mean line of y. Okay, mean of y. So the distance between this your y, sorry, distance between your yi, this particular yi, this is your yi actual value, and this particular mean line. So this is the black line you are able to see. This black line represents a total sum of square, and then sum square error is basically uh difference between this black line and this particular blue line, that is between the yi minus yi, sorry, that is between the yi hat minus this yi, means this blue line and the red line. So it's basically just imagine there are three particular things here. One is the actual point, that is the red point. Then you have the two lines, one is the red line and another one is the particular this blue line. Okay, and based upon that you have to calculate all those things. Okay, so take a snapshot of it, and then I think few of you might not able to digest two things. So just uh, take a snapshot, see the picture. So okay, so what I will there is a one thing happen here, SSR. So this is up and down thing. So I will make it up properly. Okay. Okay. Now it's perfect. Okay. So SSI, SSR, and SST. So take a snapshot of it. That will help you. Okay. Means see SSE, see yi minus yi hat square here, and then just look at this where it is. So this is the one, this is the one, and this is the one, and that will help you to know what exactly the different things means. Okay. So we will be asking some numericals on this. So take a snapshot of the formula. So which of the following formulas correctly calculates as sum of square error? So very easy thing. That's what we discussed. Okay, I think it's very straightforward stuff. So SSC means that's in simple. So next question is which equation relates SST, SSC, and SSR? You can answer for this. Okay. Just check properly and answer it. Those who are answering A, there might be the possibility of multiple choice question also. So see the formula properly. Okay, so you all are correct, but the A and D is the correct answer. Just I flip, you are able to see. Those who answer A, they are also correct, but here I told you that multiple kind answers might also be. So here I just keep means just I transfer this SSR into the left hand side, so it become SST minus SSR. So SST minus SSR is equal to SST. So both A and D answers are the correct answer. So the total variability is the sum of explained variability and the unexplained variability. That what exactly the answer for it. Okay, so this is called the extent variability. SSR means, and this is unexplained by SSC. Okay. Moving to now, what is possible range of values of R square is? So which we talked long at. What will be the R square range? B. Okay. Pretty. Okay, it's a straightforward. Yeah, your answer is correct. B is it's lie between the 0 and 1. So this is another question. If SSC is 200, SST is 800, what is the value of R square? Uh, so mm, just remember your formula of R square. And remember what exactly SSC mean and SST mean, and then you can just put all those things together, and then you will get the answer for it. Here I'm trying to relate the two things. I'm trying to relate your SSC, SST, all those things with your R square. So let's wait for the other two relate the things. You will find similar terminology in SSC, SST, and all those formulas. So you can just put there, and then just you will get the answer for it. It's very simple. Okay, Rachna, Prakashya, C. Okay. So let's move to answer. Yeah, C is the correct answer, and it's very straightforward. 1 minus SSC divided by SST. That what exactly means the R square as well. So, so you should know the concept as well here, kind of. Okay, so R square and SSC and SST can be combined together because SSC formula and SST formula is what exactly put it in the R square. Okay, so that's why I want to emphasize on this particular kind of numerical because You might know the formula of R square, you might know the formula of SSC and SST, but you might, it might be because of time or something during the examination, you are not able to relate those two things. So that's why I kind of take this example so that you are able to remember during your exam time such kind of questions are asked. Moving to the next question. If linear regression model perfectly fits the data, what would be the value of SSC? So this is concept problem. No need to mathematical thinking here required. Okay, Monia's answer yeah, yeah, it's zero. Means your error is zero. That is if something is fitting perfectly means no error, perfect everything is perfect, it's zero. Next question, what happens to R square when the regression model fit improves? Means if you remove the outliers and also then your model will again fit better way. So what exactly at that time R square? So if you prepare model one, then you do some improvements, you added some more extra feature. What improvements happen in the R square? Okay, Rachna answer to the aim R square decreases. Okay. Prakash Ranjan R square decreases. Okay. So Rachna Shirke. Okay. 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 Jagananda Rao. Okay. B answer. Understand why exactly the R square we are calculating. What is the range of R square and uh, when it is perfectly fit that you should, I think most of you just read again questions. From looking at your answers, I think you should have to go again and see what concept you learned. Okay, so the answer for it is a B is correct answer. R square will increase. Okay, so here R square ranges between 0 and 1. 0 means your seat is whatever the model you train. 0, if it's your value of R square reaching towards 0 means your model is not good. If it's reaching towards 1, it means your model is good. Okay. So R square, if your model improve, that means you are reaching towards 1, means your R square value is going to be increased. Okay. If I asked here residual error will decrease, but R square will increase. So here I asked about your R square and not about the residual. Residual means your error between the predicted value and output. So those who are answered this as A, those all people are wrong. Might be in their mind or back in the mind, they are thinking this is a, I am asking about the error. I am not asking about the error. I am asking about the R square. So read question properly. So hope this will clear. This numerical, I think, helpful for all of you. Okay. Uh, okay. So we will go to the R square and we will see different examples of this. Okay. Uh, okay. Because one example we already saw, we will see other example of this. So I will first erase other things. Okay. So this is one example we already saw linear model and this is the week 6 section multilinear model. Okay, that will we see how to do. Okay. So let's see. Okay, remove this, remove this, bring here. Okay. So here we are going to see a woman data set. Okay. So input from the environment, history, connection, and all those things. Okay, fine. So head. So this is how your data set looks like. Okay. I'll comment on this first. Okay. And then this, I'm running this. So here you are able to see the data. So your data looks like this. So I took the data of some 15 women. Collected data. I collected their heights and the weights. So these are the heights for woman one, height for woman two. So such 15 women I took the height and weights. Okay. I collected the data. Done. Now I want to calculate the relationship between the weight and height. How, if the woman is, if the woman height is more, whether her weight is more or not, something like that. I want to find a how, which kind of a relationship it has. That what exactly I want to know. So calculate the summary of data. So it will give you what exactly your values and all. So so here when I see my 15 women's data set, so I'm able to see the minimum height is 58, minimum weight is 115, and the maximum height is 72, and maximum weight is 164. Okay, that way. So this is more obese woman, and this is the more thin, that kind of woman. Or this is the first quarter, third quarter, how much values are within the first quarter, what is the mean and the medium. All those statistics are given over here. So that's what give you the day, the summary of data. So here plotting the data set right now I'm plotting. So plots you are able to see here. Okay. So I'm plotting woman versus means, sorry, weight versus height. So you are able to see some kind of trend here. So here you are able to see if the height of the woman is increasing, then the weight also increasing because she is more heighted, so more number of bone weight will be there, and that's why her weight will be also there. So that's what kind of a relationships you are able to see. Now you know the relationships here, okay, because on the single variables and all. Now we are going to fit a model here. So fitting the model, I already told you, you have to just take a LM, that is a linear model. You should know what exactly your dependent and independent picture, and then you have to put data frame. So I'm doing that way, and then I'm just running this code. My model is I'm just printing. So when I print my model, you are able to see here, I'm getting my model, and model intercept is minus 87.52 and my height is 3.45. So that's how I get my slope with respect to the height and intercept. And based upon that, I can create my model. Okay. So that's how I got here. So right now I am again plotting this. Okay. Okay. So AB line is the line once you have the model. Okay. So I store this model in this particular object. Now you want to know whatever the line we draw, these are the intercept and the slope. So you want to draw this line on your plot. So how to draw it? So AB means your kind of slope and intercept, that way they are calculating. And this AB line means it will draw the line, it will take the parameters from this particular model because we saved our parameters in this model, and from this object it is taking those parameters and drawing a line. So look in your plot section. When I run this code and you are able to see a line appears here, and this is you get a linear line for your model of it. So rather than storing all these 15 value, if you just store the beta 0 and beta value, then also you are able to view a particular answer. If you know the height, you are able to get the weight of that particular woman. So that way, this is the perfect model you are able to see here. So hope you got your answer. So model summary. If you go to the summary of the so I'm giving you the summary of this model. So in the summary, you will get more things. So in the summary, you are able to see here more number of things you will get. You will get a residual for each one of them. Means residual information, minimum residual, maximum residual, and their quartile or the medium, all those things. Here you are able to get the intercept and then the standard deviation of this and this, if you want to do t-square test and all those, and the probability with respect to that, and this will show you the confidence limit. So if you go to the professor's lecture, you are able to understand what exactly these things, extra things mentioned over here, that will help you to know the whether my model is fitted better or not better. So all those things can be done with the help of all these other things. We will not go in depth because this tutorial is not meant for that. It's basically for the understanding or solving the numerical. So we will not go in depth. For that, you just go through your weekly lectures. Okay. So that's what exactly other things. I just wanted to give you the glimpses of it. So that's what exactly done for the women's here. Okay. So we will go again back over to our presentation. Okay. So, okay, I will give you another example in the RStudio itself. So, outlier examples. Okay, so we will erase other things. So, outlier, what exactly it means? The values which are kind of not from coming from the same distribution, that is called to be the outlier. So let's consider the example that let's consider the same example, weight and height of the what we taken. So, if you took the height and weights of an Indian woman, you collected the data, and then you took some American woman height and or some European woman height and weight, then you will find that her height and weight, uh, what are the patterns, or whenever we do such kind of a plotting, so such weight and height not coming from this distribution, that will that will somewhat kind of a outside of this particular pattern which was followed by the Indian woman height and weight. Such kind of, because she's totally from another geographic region, and each geographic region had its own height and weight or kind of a pattern. So such kind of people or kind of outlier. So in whenever you are sitting in your group, someone is speaking kind of English things, there is some people who speak the English, but if you don't know the English, so that based upon that you will say this is the outlier guy who don't know the English and all. So based upon that, groups in your college and fall, college groups will be formed and other things. Okay. So that what exactly the outlier, that's what we are going to see in the data also. So in the data also, we are getting the outliers and we are going to see the same over here as well. Okay. So we are going to see one of such examples. So I take some random values. Uh, I'm I'm putting those value in there here, x and y. So here I'm taking some generate some, this is particular equation I took. I took three is my slope plus particular this random value that I'm choosing. So I'm creating some relationship based upon that I'm having the y value, and then introducing outlier by modifying 10. So I'm just modifying the 10 value. So I'm just putting the 10 outer value, and then I'm just replacing it in the data set. And I'm preparing the data. So I just have some 100 sample for each x values and I'm having some y values. Okay. So I prepared the data. Okay. Then I'm plotting the data. So just see what I'm doing here. I just plotted the data. So this is how my data looks like. So here uh, I took this for these are the temperature and these are the pressure. Okay. So for each temperature, there is a pressure associated with that. But there are sometimes, let's consider if you are in the, I am a chemical engineer, so I'm just taking the example of temperature and pressure. So here there are some fluctuation in the production, or there are some maintenance going on. So at that time, such kind of outliers will happen, or you are shifting from one grade of the product to the another grade. So in that case, such kind of things will happen, and you will get for some temperature, you are getting some high pressure or some random values or some sensor failure, you will get some kind of a values for getting. So in our case, we are getting some these particular 10 values, which are just by looking in this particular graph, you are able to see these 10 values not matching the pattern. So what we will do here, we will first prepare a model considering all these 100 values, that we will do, and then we will after plotting and all, we here know that these are all 10 values are outliers. So we will remove those values and we will train our model again, and we will see how the difference between the two models. Okay, that's what exactly help you to know what exactly I iterative, this whole process is iterative. So this what exactly I mean. You have to look at the data, you have to see what exactly it matching my trend or not, why that particular is the outlier, is there any importance of that outlier or not. If your sensor failure happen, then some random pressure value will come. And even if you're taking that sample, then you are doing something wrong and you will get a very bad model. Okay. So I'm fitting that model. Okay. So here you're able to say I'm fitting that model. I fitted that model. Done. Summary of that model given here. And I'm plotting AB line for that. So I plotted some red line for that. So you are able to see. So for this data, all this data, this is the red line because I am considering all 100 points here. I'm okay. I not removed right now this all outliers. Okay. So that is my line. So what I'm doing here again, I know the index of this outlier. So I'm removing the index. So don't look into this particular how I did it. I will share this code to you. You can look into your home. I again train the linear model to, and this is the summary. And again, I'm drawing the both. Now you can see the difference. Okay. After removal, okay. It's what happened. Okay. Okay. So you are able to see the difference. So this is your red one is it is when you have the outlier and when I train my model, and when you have the green when you remove those outlier. So that's how we developed our model or we improved our model. You are able to see there is an improvement. And this is green line is better model because the error which is giving over here by this green line is more lesser than that of this red line. So that's how the model improvements, all those stuffs are done over here. So this is giving you the another version of it, how this is the iterative process and how the things works while doing the model development and all. Okay. So, so that is the one of the way. Another way is the hypothesis testing. So hypothesis testing, basically we are testing whatever the B1 value we are getting here, whether that B1 value, if that B1 value is zero, means if your slope is zero, then whatever X value you will put, that is going to give you no effect on the Y value. Means your beta one is not, means your output is not dependent upon your input. Okay, that's what exactly. So that what exactly here testing with the help of the hypothesis testing. So in the hypothesis, generally we want to avoid the null hypothesis. Okay. So here null hypothesis I'm taking beta 1 is equal to 0. Since my slope is equal to 0, that exactly means uh, my feature is not dependent upon my feature on is having no contribution in my output. Okay. Alternative hypothesis beta 1 is not equal to 0, means beta has some value. So null hypothesis implies that this is the reduced model, that is called to be the terminology reduced model, and this is called to be the full model, alternative hypothesis. Okay. So so based upon that, we are going to do the hypothesis testing and all, and we will do the testing of we will do the hypothesis testing, two-side test and all, and based upon that confidence interval, we will say that yeah, this means null hypothesis is true or the alternative hypothesis is true. So if alternative hypothesis is true, and then you are good to take that feature. Otherwise, if null hypothesis is true, then you should remove that feature because that feature not contributing anything into your model. Okay, that's how hypothesis testing works. I will not go in depth of this, just see the professor lecture, as well as we already covered these during the probability and statistics things, how hypothesis testing works. Okay. Another way, okay, so this here I want to give the another glimpses of the things. So next step is to check the linear fit and all. So this is the Anscombe Ansombe data set. This is the linear regression of Ansombe data set. Ansombe data set is kind of a data set which having the different pattern, but the results you are getting the same result. So this is kind of a data set uh, given over here to give the glimpses of it. Because sometimes someone will say that my R square value is one. Okay, that does not get, but there is assumption for R square that both linear means your dependent and independent feature are in the linear relationship. That's for assumptions of the R square. Okay, but if it's your relationship itself is a non-linear relationship, in that case, R square, even if it's one, then you cannot say it's a good fit or not. Okay. So let's take this example, linear regression example. So here, these are the four different patterns you are able to see here. One is this kind of a pattern of your sample. Here you are able to see very beautiful pattern, but a linear regression pattern. Here you are able to see again a linear pattern, but you have a particular outlier here. Here you are able to see no pattern, just a single value you are able to see, okay, and just some outlier or something like that. So when you train a model on all this kind of a data set, you are getting the same model. So you are able to same model means you are getting the same R-square value. So R confidence interval for linear regression hypothesis test all gives identical results for all four kinds of a data set. Okay, because it's just a mathematics calculation it is doing. But here you are able to see if such kind of a data means if this is the correct data, but if you get such kind of data, then you are building some wrong model, some wrong linear model. This is also you are building some wrong model. Okay, here also you are building some wrong model. This model should be directly straight line. Okay, straight vertical line. This line should be like this. Okay, so in that case we have to remove all those stuff. So how we study this kind of a things? Okay, here we are able to see very easily because there is a only two variable, but in case of multivariate, it becomes sometimes difficult. So there is a way to analyze this. So one of the way is kind of a residual plot. So there are different ways to do these things. One we saw the R square, if the value between 0 and 1 range. Another we do with the help of the just by looking into the plots, we are able to guess something, outliers and all. We saw that our examples. Another with the help of the hypothesis testing also we saw the example. So there are different ways to do this, and it's depend upon your data set, on your intuition, which you can follow different ways to see whether your model is good or not. That we can do. So residual plot is one of the way to analyze this also. So how you can look into this kind of plot. So I am plotting this residual. Residual means y minus y hat. That's what exactly I mean by residual, and that's what exactly plotted over here. Look for the pattern. If you just plotted the residual, look at the pattern. If the pattern is random, then that particular model, you can consider that model is a valid model. So in this case, this is the residual for that. This is the random residual you are getting here. And and that's why this is, you can say, a valid model. But if you are able to see the patterns, so that is not a valid model. You have to go and see the patterns of your data set. So you are able to see some patterns. So this is a non-linear, beautiful non-linear pattern you are getting out of your residual, and that tells something that you are missing in this. Okay, so you are missing that this is a non-linear thing, and you are fitting a linear model on that. Shape of the information on the shape of the pattern will tell you the information. So here also you are able to see. So this is giving you the error of some, and some particular random sample giving the error of 3. Here it's getting the error of near to 0, but here it is giving the error of 3. So you can just remove it and again train the model. Here you are able to see again error, some kind of a error like that. So based upon the pattern, you can decide what to choose, what to select, how many sample. Okay. So this is one of the ways. So I'm just showing you the different ways to do this. This is the RStudio. Okay, so this is the multivariate linear regression. So where I generally saw here beta 0 and beta 1 x1. So multivariate linear regression means you have the multiple features x1, x2, x3 for that beta 1, beta 2. So these are the slopes associated with that. Okay. So using an observation, estimate the regression coefficient. So that's what exactly. So I will give you the example, the better way to understand this with the help of the RStudio, what exactly the multivariate linear regression, okay, rather than just seeing the maths of it. Okay. So multivariate linear regression. So I'm taking two variables here. Okay. So for that, I will just erase other thing stuff and then we will look into it. Okay. So this is, I will not go into the code. Okay. So I'm first generating the data set. Okay. So I'm generating some 100 numbers. So variable one means x1, I'm generating the x1 values. So some 100 x1 value, randomly values, x2 value are generated. Generate the dependent variable. Let's assume that the true relationship. So this is my true relationship. Y is equals to 2x1 plus 3x2, and I am generally in the real world. There is no perfect thing exists. So that's why I'm adding some, making it some realistic. I'm adding some random error to it. Okay, that's what I'm doing here. Okay. Okay, so error I'm adding, so error I'm generating, and that's what I generated here, 2x1 plus 3x2. That's how I prepared my database. Uh, and this is how your data will looks like. This is your x1 value, this is your x2 value. Here I'm taking the two feature. You can extend this to multiple feature, and this is the y value respect to that. Okay, that's what you done. I don't know whether we trained the model. Okay, we trained the model. Uh, okay, okay, sorry, we are in different file. We should be in this file. Okay. So we are already calculated. We will see the head of the data, how data looks like. So head is calculated to generate the top five value. Okay. Then parameters. Okay. Then so you are able to see the scatter plot. Okay. This is the scatter plot of. Okay, I will zoom it. So this is how the scatter plot looks like. The relationship between the x1 and x2. So this is my output, and this is x how they are related with each other. You are able to see this is how your scatter plot looks like between the two variables. I'm running an code. Okay. Again, I'm able to see, you're able to see two plots, how your y and x2 related with each other. So this is how x1 values and this is our x2 values. So I plotted for both. Okay. But we have to see the combination of both and all this, right? So I'm fitting that model, linear regression model. Okay. And then, okay. Uh, okay. So it's installing some library. So let's wait for some time. Uh, mm, okay, I think it's done. Okay, fine. Okay, it's done. I'm plotting. Okay, just see my plot. Okay, then we will discuss all the other things. Okay. So for that, you are getting three values. Okay. So here you got three values, 1.8, ABC means your coefficient and all. Okay. So I'm trying to tell you the story in more better way. So this is how I plotted this in the 3D plot. So one is x1, another one is x2, and the third one is your y value. And based upon that, the model is trained. So here you are, I am hope you are able to see the 3D plot. So we saw one dimension like this. Okay. Uh, this is the way we saw our plot. This is your y value and this is your x1 value. That way we saw. So this is the pattern we looks like. We saw another way x1 and x2, and this is the 3D way. So here your y x1, this is your y value, and these are your this is your x2 value, this is your x1 value, and you are able to see. And this red points showing you your sample location, whereas the blue plane you are able to see here, that what exactly y- your model is. For the particular x1 and x2 value, you are getting this y1 value. Okay. Hope you are able to see this plot. These are your 3D plot, and then this is blue plane is your particular model which we prepared. Okay, so that's how your multivariate. So this is we are able to visualize this because this is only three dimension. But if it's become a 10 to 15 dimension, it's not possible for human to imagine. So here we have plane, but if you go to the 3D space or the 4D space, then whatever the model you are getting, it's a hyperplanes you are getting. Hyperplanes means the plane which is in the multiple dimension. That is beyond the possible imagination of the human being. So that's how multivariate thing works. Okay. Hope that helps. That figure helps you to understand the thing. So that's it for today. From my side, we already cover all the things which is required for the solving the your numerical questions and answer. So that's it from my side. Thank you. If you have any question, you can ask, or if you want to leave, you can leave the session. That's it from my side. Thank you. Thanks to all. If you have any question, just put, or you can switch on your mic and you can just speak. Or if you want to leave, you can leave. Thank you, Fahad. Thank you. Thanks to all. Or if you have any feedback, you can give to me feedback so that I can improvise on my slides or my way of talking. So I will upload PPT or as well as the code what we have run here. So I will do upload that so you can try on your system how things works. Uh, if you have any doubt in anything means not understood or something, just ask. Uh, Floor is open to you. It's in the Sveto, I can't say whether it's easy or hard exam. It's depend upon how much you study. Oh, okay, so Shreya, where it is uploaded. So when you go to the NPTEL, na, so where you are getting the link of my videos. So in the SWAYAM portal, I have to log. Let me log. Okay, let me log in SWAYAM portal here. So I will show you here only. Uh, Sorry, I think sign in required. I'll stop this first.